Welcome back to second semester. I hope you all had a wonderful winter break. We're going to begin Unit 6. Unit 6 has a lot of information in it, and we're getting into a lot of what chemistry is, which is really exciting. We have chemical formulas and bonding. When we look at chemical formulas, basically we're going to be looking at ionic and molecular compounds. When we're looking at bonding, we'll be looking at ionic, covalent, and we'll also introduce metallic bonding in there. Later on in the unit, we'll be looking at molecular shape, such as how will we describe the molecule. We'll be getting kits out and putting them together, and we'll be looking at the polarity and the Lewis structure. We'll learn how to draw Lewis structures for your molecules also. First off, I want to let you know that my videos are not perfect. I hope that they come out clear. I'm not a little excited about the sound quality of the video, but hopefully it doesn't sound too terrible. My dog may bark, my cat may meow, you may hear one of my girls or my husband, the doorbell, anything is possible. So just be ready for surprises. Also, at any time, pause the video to fill in your notes or rewind it to maybe catch something that maybe you need to hear again. That's the nice thing about the video, is you rewind me in class. First off, when we are looking at formulas, we're going to be using symbols to write your formulas. So remember, your symbols are your abbreviations for your elements on the periodic table. Like potassium is capitalized K, calcium is capitalized C, lowercase a. It's really important that you get to learn those abbreviations, especially for your ions, and you study them and their charges, because that's going to be so helpful throughout this unit and the rest of the semester. Also right now, because they're new to you, have that ion out when you are practicing, especially with the practice problems that you get today and next week. First off, chemical formulas are going to tell you exactly your chemical symbols, and it also will have numbers in there. So it's going to tell you what's your composition, what type of elements are in there, and exactly how many of each atom or element you have. When we're looking at molecules, molecules can consist of a single atom, two or more of the same element or atom, or a compound where it's made up of two or more different elements. Monoatomic is going to be an atom that is just, or a compound, excuse me, or a molecule that is made up of one type of atom, such as a noble gas. Diatomic, di means two, so that means you have two atoms. Typically, they're going to be two of the same type of atom, like oxygen is O2. You'll never find a single oxygen atom by itself. It's always going to be O2. Most of your elements in nature do not occur in their elemental form. They occur in compounds. We'll be looking at qualitative and quantitative analysis, but a little bit differently. Qualitative could be like, okay, if we have a compound, what are our elements that make up this compound? Or what type of compound is it? Is it an ionic, or is it a molecular compound? Quantitative would be telling us maybe the mass of our compound. So what is the mass of each of the elements that make up the compound, or the total mass of the compound? The three kinds of formulas that we're going to be looking at a lot in this unit will be empirical formulas, molecular formulas, and structural formulas. Today we're going to work a lot with empirical and molecular formulas. Empirical formulas is where you're looking at your simplest whole number ratio of your elements in a compound. So if we're looking at these two formulas, CH versus C6H6, CH is your empirical formula because it's reduced to your simplest whole number. We can divide these sixes by 6 to get 1. Also notice in chemistry we do not write one. So anytime you just see a C or an H, it's understood that we know that there's one carbon and one hydrogen. A molecular formula is going to show the number of atoms of each element that you have in one molecular substance or one compound. In most cases, you're working with nonmetals, and sometimes your empirical and molecular formulas are the same. And we'll look at an example of these in just a moment. So again, we're going to look at the same formula, CH versus C6H6. Again, this is your molecular formula because it shows you have exactly 6 carbon and 6 hydrogen. We do not reduce it. Structural formulas are going to allow us to see how your atoms are joined together. On this next slide, these are all examples of structural formulas. So we have kind of a bent shape here with hydrogen in this, oxygen in the center and hydrogen branching off, or a linear shape here where we have carbon in the center and oxygen on the outside, or kind of like a T shape where you have nitrogen in the center and 3 hydrogen. And then we have benzene, C6H6. This is an organic compound. This is what we refer to as a ring structure. All of your carbon are connected together, and they're alternating double, single, double, single, double, single bonds with the hydrogen on the outside. So let's take a look at a couple of examples of molecular formulas. So in this case, this is a molecular formula here. And I'm asking you to reduce it to your empirical formula. So just ask yourself, what number can I reduce the 12 and the 24 by? Well, I can reduce it by 12. And then my formula then would be CH12. When I look at my formula here for water, H2O2, can I reduce this down? I can't, because if I would try to reduce by 2, I would end up with half of an oxygen. I can never have half of a molecule in a, or half of an element or atom, in a compound or a molecule. So in this case, this is both your empirical and your molecular formula. If you look down here, we have another compound called H2SO4, and this involves our polyatomics. And you've kind of seen a couple of polyatomics on that ion list. Hopefully you've been looking at it. They're more with your anions than your cations. And polyatomics, you cannot touch them. I'm going to talk more about them. So that means that, first off, you can't reduce the sulfur any further by 1. Okay, so this is your empirical and your molecular formula. But I could also ask you to make this empirical formula and change it into a molecular formula. So let's just say, let's use the number 2. And in this case, we're going to use the distributive property in math, and we'll distribute the 2 to both the hydrogen. So that means we now have H4, and we're going to put parentheses around the SO4. We're going to talk more about that need in the next video. And the 2 can go outside of the parentheses because this is understood to be a 1. Because polyatomics, SO4, we can't change it. We cannot touch it, but we can put parentheses around it and change it on the outside. So now we've just changed our empirical formula to a molecular formula. So we go back and reduce that, you bet we could divide by 2 and get that same formula back that we had before. And with this formula here, you already have your parentheses around the NO3, so we know we cannot change what's inside of the parentheses. But can we change what's outside of the parentheses here? You bet. So let's use the number 2 again. We could use any number we wanted to make this into a molecular formula, but let's just all use 2 so it's the same. So that means our formula would be Cu2 parentheses, NO 3 parentheses, and then that would be a 4. So this is very similar to the homework that you're going to be practicing.